Quantum mechanics is one of the most fascinating and complex fields in science, but it's also one of the most misunderstood. Over the years, quantum physics has inspired not just groundbreaking discoveries but also countless myths, misconceptions, and misinterpretations. These range from pop culture distortions to outright pseudoscience. Let's explore some of the most common myths about quantum physics, debunk them, and reveal the truth behind this extraordinary branch of science. Myth number 1. Quantum physics is purely mysterious and impossible to understand. The myth, quantum mechanics is so weird and complex that only geniuses like Einstein or Schrödinger can understand it. The reality, quantum physics is indeed counterintuitive, but it's not incomprehensible. Many of its principles, like wave-particle duality and quantum superposition, can be explained in ways that even beginners can grasp. Scientists use mathematical frameworks to predict and explain quantum phenomena with remarkable accuracy. For example, while the idea of a particle existing in multiple states simultaneously, superposition, seems strange, it can be understood with basic analogies, like flipping a coin that's in a mix of heads and tails until it's observed. What makes quantum mechanics challenging is not its inherent mystery but its divergence from everyday experience. The microscopic world operates on principles that are simply different from the classical physics we encounter daily. Myth number 2. Quantum physics proves consciousness creates reality. The myth, the observer's consciousness collapses the wave function, creating reality itself. The reality, this misconception comes from a misinterpretation of the observer effect in quantum mechanics. The observer effect refers to how the act of measurement influences a quantum system, collapsing its superposition into a definite state. However, the observer, in this context, does not need to be a conscious being. It could be a camera, a particle detector, or any interaction with the environment. The idea that consciousness creates reality became popular due to misreadings of interpretations like the Copenhagen interpretation, but there's no scientific evidence supporting the claim that human thought or awareness directly shapes quantum states. It's more accurate to say that interaction, not consciousness, drives the process. Myth number 3. Particles can teleport instantly across vast distances. The myth, quantum mechanics allows particles to teleport across the universe instantly. The reality, this myth likely stems from the phenomenon of quantum entanglement, where two particles become correlated in such a way that the state of one instantly affects the state of the other, regardless of distance. Einstein famously called this spooky action at a distance. However, entanglement does not mean particles teleport or communicate faster than light. Instead, it reflects a deep connection between particles' states, established when they were entangled. Importantly, no usable information can be transmitted faster than light using entanglement, preserving the cosmic speed limit set by Einstein's theory of relativity. Teleportation in quantum mechanics does exist, but it's not like the sci-fi version seen in Star Trek. It refers to quantum teleportation, a process where the state of a particle is transferred to another particle at a distant location, with the help of classical communication and entanglement. It's a sophisticated process that requires both quantum and classical channels. Myth number 4. Schrödinger's cat is both dead and alive. The myth, Schrödinger's cat is a real experiment that shows a cat can be dead and alive at the same time. The reality, Schrödinger's cat was never intended to be a real experiment. It's a thought experiment designed by Erwin Schrödinger to illustrate the paradoxes of quantum superposition and measurement. In the scenario, a cat is placed in a box with a mechanism that has a 50-50 chance of killing it, depending on the state of a quantum particle. Until the box is opened, the cat is described as being in a superposition of dead and alive states. This paradox highlights the absurdity of applying quantum mechanics directly to macroscopic objects. In reality, quantum effects like superposition are not noticeable at the scale of a cat because of decoherence, the process by which quantum systems lose their quantum properties when interacting with their environment. Myth number 5. Quantum mechanics supports free will or mystical ideas. The myth, quantum indeterminacy, means we have free will, or it proves mystical concepts like the soul. The reality, quantum mechanics does introduce uncertainty and randomness at the microscopic level. For instance, the exact moment when a radioactive atom will decay is unpredictable. However, this randomness is not the same as free will. Free will involves conscious decision-making, while quantum indeterminacy is simply an inherent feature of how particles behave. Similarly, while quantum physics has inspired philosophical and spiritual discussions, it does not provide evidence for mystical ideas like the soul, parallel consciousness, or universal energy fields. Claims linking quantum physics to spirituality often misuse terms like energy or frequency without scientific basis. Myth number 6. Everything is quantum, including everyday objects. The myth, quantum mechanics applies to everything, so everything behaves in a quantum way. The reality, while quantum mechanics governs the behavior of all particles, its effects are most noticeable at microscopic scales. Everyday objects, like chairs and cars, follow the rules of classical physics because quantum effects are averaged out due to the sheer number of particles involved. This is why macroscopic objects don't exhibit phenomena like superposition or entanglement. They are governed by classical approximations of quantum laws, which are sufficient to describe their behavior. Myth number 7. Quantum physics is completely detached from real life. The myth, quantum mechanics is just theoretical science with no practical applications. The reality, quantum mechanics is the foundation of much of modern technology. Its principles are essential for the development of semiconductors, the basis of modern electronics, including computers and smartphones. Lasers, used in everything from medicine to communications. Quantum cryptography, ensuring ultra-secure data transmission. Quantum computing, promising to revolutionize computing power by leveraging quantum states. Quantum mechanics is not just a set of abstract theories, it's a practical, powerful framework shaping the modern world. Quantum mechanics is undoubtedly strange, challenging our understanding of reality. However, it's crucial to distinguish between what science tells us and the myths that have arisen around it. Misconceptions often arise from oversimplified explanations or attempts to fit quantum concepts into everyday frameworks. By separating fact from fiction, we can better appreciate the true wonder of quantum mechanics, a field that continues to push the boundaries of human knowledge and redefine our understanding of the universe. Stay curious, but always question claims that sound too good or mystical to be true.